In this video, we'll be covering acceleration. While velocity is defined as change in distance per unit time, acceleration is change in velocity per unit time. This gives acceleration units of meters per second, or meters per second squared. This may sound obvious, but different objects have different values of acceleration when they're in motion. But could you confidently say what a reasonable acceleration for an athlete starting a race is? Being able to estimate a reasonable value for acceleration is useful in itself, but it also helps us check exam answers. Some common accelerations are as follows. A car has an acceleration of 2 to 3 meters per second squared, if driven sensibly. A falling object has an acceleration of roughly 10 meters per second squared. A rocket has an acceleration of 30 meters per second squared. A Formula 1 car is around 50 meters per second squared. And to achieve accelerations of above 100 meters per second squared, you would need to be in a fighter jet. Memorizing at least 3 of these values will help you double-check any answers for acceleration questions in exams, and you might be asked to estimate the acceleration of any given object in an exam. To calculate acceleration, we need the change in velocity, and we divide it by the time taken for it to change. The change in velocity is defined as final minus initial velocity. It's important to get this the right way around. Initial velocity has the symbol u, and final velocity has the symbol v. So we can write this equation as a equals v minus u over t. As an example, this bike has an initial velocity of 0 meters per second and a final velocity of 5 meters per second, and it takes 2.5 seconds to move from initial to final velocity. Substitute the values listed into the acceleration equation, making sure to do final velocity minus initial velocity, and that's our acceleration, 2 meters per second squared. A few things to note. Change in velocity can also be negative, for example if initial velocity is greater than final, which means the object is slowing down. In this case, the object has negative acceleration. This means it is decelerating. Most students can remember the equation, but so many get tripped up by putting initial and final velocities in the wrong place. This question is a great opportunity to talk about positive and negative velocities. In the future, on an unknown planet, an astronaut throws a ball upwards with a speed of 2.5 meters per second. 8.0 seconds later, the ball is travelling down to the floor with a speed of 4.3 meters per second. Calculate the acceleration of the ball and give the direction of acceleration for 3 marks. Notice how the ball is travelling in 2 opposite directions in the question? To help understand this scenario, we are going to draw a diagram. The ball is thrown up, reaches its maximum height, and then starts falling downwards. The time taken is 8.0 seconds. Its initial velocity is 2.5 meters per second upwards and has the symbol u, and its final velocity is 4.3 meters per second downwards and has the symbol v. To show that these velocities are in different directions in our equation, we need to give them different signs. So one will be positive and the other will be negative. We can choose which direction is positive, either is fine. But we'll say upwards is a positive velocity, so downwards is therefore a negative velocity. Now, when we list our quantities, initial velocity u is plus 2.5 meters per second, and final velocity is minus 4.3 meters per second. We'll also include our time of 8.0 seconds from the question. Now that we've got the correct signs on our velocities, the rest of the question is easy. We recall the equation, a equals v minus u over t, and substitute in the values from before. Putting these into the equation gains the first mark. Just put that into a calculator, include your units for acceleration, and you get a second mark. All that is left now for the third mark is to explicitly state the direction of acceleration, like the question asks. The acceleration is negative and up was the positive direction, so acceleration is downwards. You can get the exact same result by defining down as the positive direction. Give it a go if you want to further your understanding of these types of questions. In this video, we covered the definition of acceleration as the rate of change of speed with units of meters per second squared. Acceleration is a vector quantity which is calculated as change in velocity divided by time, and you need to take care when looking at the directions of final and initial velocity, as their signs could be different.